Well, it seems like we have some Next Generation fans in the audience today. Star Trek The Next Generation. Rob is not a fan, he just is culturally aware. Yes, and I chose this GIF because this talk is all about data.
Yes.
Data. Now, we could just jump right in and start talking about the formula, like how do you calculate a regression? But this is what the formula looks like. It's just like, I don't. So Rob, do you want to like hop up here and like tell us what all this means?
No.
No? Okay. Well, fortunately, we have the internet to help us to understand what we mean by regression analysis, linear regression. This is from the Explain Like I'm 5 subreddit. So thanks to the user FaceWeight, it's a way to guess what's going to happen based on previous information. And that's really true because we're taking the previous information and we're putting it into a computer and we get charts like we saw in Cotton's presentation and Hiromi's presentation and someone else's presentation. I feel like there was Matt's presentation. So we're gonna take a look at some ways that we can use this data and what it looks like, and we're gonna be able to predict the future, but also verify the present. And we're gonna talk a little bit about that. It's not gonna be like a super deep dive sort of thing. We're not gonna like actually like throw numbers into anything like Matt did, which was beautiful and amazing, and I wish I'd like remembered that Google Forms was a thing. I was super jealous yesterday. But we're gonna sort of focus on like the modeling of this thing. Like how do we design a regression analysis thing? How do we put these charts together, and what are some ways that we can use this as designers to verify assumptions, knock assumptions off the shelf like a cat, just knock it right off the shelf, and how can we use it as a tool to sort of verify some assumptions that we were pretty sure are right, but we're not sure. So let's talk a little bit about what the parameters of a regression is. So we've got two variables, and a variable means like it's this one variable is this thing that can change. We define a number here, a number set here. On the other end of our x, y, or y-x chart, there's another variable that is also quantitative data. So variables can be quantifiable and contextually related. Like you're not going to get any valuable data from like what's the weather going to be like tomorrow if you're trying to guess how many tomatoes are going to be ripe in your garden tomorrow. Like there's just like, that's not related to anything. But you might be able to look at models of past weather from this region over the past 20 years and be able to maybe make a prediction based on this current weather pattern, what the weather might be like in a couple of days. So that's quantifiable data that you have this historical data, and you can collect it. So I thought it might be fun to come up with an impractical example and just purely conjecture, no real data. Is a banana sweeter the older it gets? So we have our two variables. We've got the age of the banana, right? And then we have the sweetness of the banana at a certain age. Now, if you're like me, this matters to you because you might buy 6 or 8 bananas at the store and let them ripen on your counter, right? And then at a certain point, you have a pretty good guesstimation that it's gonna be pretty sweet so that you can pop it into the freezer, and then in a couple of days you can make a chocolate banana shake. Like you take the frozen banana out, you put it in the blender, you put in the cocoa powder, and you don't even need anything else. Maybe some like coconut milk, or if you're not lactose intolerant, some like actual cow milk, and you blend it all up and you got like a really nice, tasty frozen treat. It's basically guilt-free, unless you have a lot of it, like a lot. like a lot of bananas. Okay, so here's some data that I just like totally pulled out of the air, went into Illustrator, used the blob tool. This is not real data. It's totally impractical. So we have our dependent variable, which is the y-axis, and this is the thing that, for the purposes of this data plot, is our dependent variable. We're comparing something else against it, and then we have our sweetness on the x-axis here. And what we're looking for is a pattern. And right away, with this type of data, only two variables, you can kind of see that there's some kind of a progression here. Like we have a couple of points here. Somehow we were able to scientifically measure sweetness in this chart. I don't know how we did that, but we did it. And then we have the age of the banana. And as the age gets up, it goes higher, 4 or 5 days maybe, then the sweetness is comparably progressing. And then if we're using a linear regression model, like we saw in some of our presentations earlier, we're going to use math to calculate this straight line through the center of the data. And we're going to see in a second how we might be able to make a prediction based on these results and the math that we're looking at here. Now, what Matt's presentation was showing us and what Hiromi's example yesterday was showing us was actually 2 lines through our data, and that's known as a multiple regression. And that's where we can get these like separate fields, one at the top, one in the center, and one at the bottom. And what's really useful about that is then we're looking at the markets that are adequately served, the ones that are underserved. So we have 3 fields of data that we can use to make decisions. But for the purposes of this, we're going to say maybe at the 6th day, we have our optimal time to freeze the bananas for our shakes, right up here. And so we could make a pretty reliable prediction based on this progression that we see as to when the optimal time to make our milkshakes is. So the next question is, how can we practically apply this? Because I don't want anybody to feel like this is a waste of time. I could just end it here and just hang it on this GIF, and at least I end on a high note, right? We could do that. But I thought a pretty good way to look at regression analysis is kind of like the painter's tool. I don't know, anybody ever use a painter's tool or have one of these things? It's amazing, right? You use it at the beginning, like you can prepare your work area. If you're like painting a window, you can scrape off the crud on the side of the window. Like the last person who painted the window left splotches on the glass. The blade right at the edge just scrapes it right off. I don't know what the circle thing is for. I assume it's for, yeah? Oh yeah, you get the paint off your roller. That's good. Yeah, that could be useful. At the end of the process, you've got this sweet handle, and you can just bang the paint can lid back on, right? It's this kind of tool that through the entire process of painting, we can probably find a pretty practical use for it in our tool belt. So here's some opportunities for regression analysis. At the beginning of a process, we might be able to conduct some interviews related to the current jobs that people are doing, establish a Likert scale, the things that are satisfying to them, things that are dissatisfying to them, and then we can collect all of those quantifiable responses and produce a linear regression from that. During the process, we could maybe do some A/B testing. Maybe we have a current design and we want to enhance it in some way. So perhaps put those 2 designs in front of real people, establish like a beta program. If it's an e-commerce application, push this version of a page to some people, push that version to other people, and see how long it takes them to convert their business for our clients. And then just kind of repeat that. So we have this sort of cyclical tool at our disposal. As we ideate through a process, we can make a prediction, perhaps, which is the best one to apply to a design, which is the best solution to apply to a design, and then keep proving our results through using linear regressions. So we're basing these things on real data. We're not basing them on our gut or assumptions, but we have kind of a scientific approach to making real decisions. So we looked at that formula before, and I would love to take 6 months and really learn all the ins and outs of that formula. But I just, we don't really have the time. We're not really data scientists. There are people out there that we could engage to do data science for us. But there are plenty of tools available. Like the first one that I saw over and over and over again in my research was how to plot this data in Excel. Totally could do that. There's tons of online generators. They're pretty ugly. They're really kind of difficult to learn how to use. The Google Forms was pretty nice, but I think it falls short because it doesn't calculate the linear regression for us. But we can capture that data with that tool. There's a lot of JavaScript libraries out there, and I assume that if we do enough research, we can find a tool that we can reliably use over and over again to accept our data and to generate actionable results from that. Also, if you want to use this tool, if you want to just keep it at the back of your heads, what works for you? Maybe numbers on your Mac works for you. But how can we have a repeatable process in place to keep this tool in the tool belt?